Okay, this is the second presentation about forming, about 14 slides, and we're going to talk about warm and cold forming. Warm working is done below that Curie point where the material has not become plastic. There's a point at which there's an annealing process. So some of the rolling processes are done this way where it's not really um, heated, not to the plastic point, but rolled out into a form that just under great pressure goes from a different thickness of material. Um, so grain structure doesn't matter, doesn't isn't changed, but it does have some advantages. It's not a very big process, but this is a good time to talk about heat treating of steel. Um, it's going to be very brief, and you can make steel harder by heating it up past that Curie point and then quenching it right away. Remember how the grain structure changes when you get to that good, or it does change when you get up to that Curie point. It becomes small and more dense. And in fact, the crystals change from one shape called body-centered cubic to, excuse me, from body-centered cubic to face-centered cubic, which doesn't decrease the size or anything, but it does increase the relative density of the steel. And if you can freeze it at that point, you can actually make the material harder. And uh, where is this an advantage in that you can take a mild carbon steel, which is easy to machine, and then heat treat it, and it will act more like a high carbon steel in terms of hardness. This was one of the first ways that they made camshafts and um, for automobiles is that they would heat them or machine 1045 steel and make the complex shapes and the cams and all the things that were needed, then heat treat that camshaft, um, and then it would have the strength of 1080 steel, which is much harder. Um, Steel that's like 1095 is high speed steel, so you can imagine the larger that second number is, the harder the harder the steel. And so they could make parts that were easy to machine but would be usable in where they needed the hard processes. Um, Annealing is a process, and that everything you buy, when you buy a piece of steel, it has been annealed because it's probably been rolled into this warm working process. Um, but even if you've finished your part, you could anneal it by um, to improve some ductility, flexibility on it by heating it below the Curie point and then letting it cool gradually. Now, if you heat it to that Curie point and then quench it, you do a process called tempering, and that improves the durability. So when you're buying tools and they say they've been tempered, that's the process that they've gone through to doesn't necessarily make them harder, but it does make them more durable. Okay, the rest of this is about cold working and room temperature, basically. Um, Now, as I said, if you wanted to bend a half-inch thick plate of steel, you could get the machines to do it, um, but you'd probably want to hot work that because it'd be easier. But you're really looking at thin sheet material. You're mostly talking about sheet metal. Um, there are some things that are changed in some of the bending processes. You get an internal heat stress that can called strain hardness, and it's like the um, heat hardness that I was telling you about, but it becomes internal. advantage is it's no heat. Just go out and do it. You're going to get better surface finish than hot working. Is not as good a surface finish as machining or chip removal, but it can be pretty nice. You can have very good dimensional control. Quite often you don't need a secondary operation. Because of this, some of these processes, you will end up shaping it, and then if you have to machine it again later, it's because of that stress hardening, it can actually improve machinability. And again, those where the strain hardened segments where it's bent um, will won't wear away as fast. But that strain hardening has a negative too, in that it can make that point that was stressed more brittle. So you may have a place that's exactly where it's going to break, even though it's harder. And you generally, if you're looking at thick steel, it's hard to do. I've mentioned that a couple of times. And there's can be some serious calculations. The little folding that we did for making your artifact box is, some of you may have found along the edge where it folded, it was kind of cracked. What you've got is a problem where one side of the fold gets scrunched and the other side gets stretched. I don't want to go into a whole lot of the details here, but it can create some compression and stretching issues if you don't calculate the radius properly, particularly in pipe bending or tube bending. Very popular for making a lot of products. But a lot of times you set it up to have machines make one part or 3 or 4 parts, and they just run all day long, stamping out different processes, different things. Very good for high volume. And the big high volume manufacturers like appliances and automotive are very big on this. The basics of a punch operation, or the punch and the die. The punch is the part that's attached to some sort of ram or something that moves. The die is usually stationary, and the material is around it, and it takes on the shape of the dies, on the shape of the finished part. If they're in progress, you might do part of it and then keep putting a different punch in, or you might be cutting it out. Could be doing either one. And here's just a diagram of it where you've got a metal piece in there, and the ram comes down with the punch, and it punches out. And in this case, the blank follows through the opening and goes out. And question there is it piercing or blanking? And that is the workpiece, the part you punched out, which is quite often the case. You want to have a round disc that would then go to some other place to be formed, or do you want the workpiece to be that long piece of metal, like a strap for a steel shelf? And these are 2 different processes. Blanking is cutting out the piece that you want the workpiece, and the scrap is the excess part. And piercing is where the main piece that's going through and is the workpiece. It'll be used in some part, maybe wrapping around some insulation around a duct, but you want to have some holes where you're going to attach bolts to, and that is called piercing. you'll see some on one of the videos, um, not one of the ones under the single process, but one of the main ones in this unit, in this module, um, can create some pretty complex shapes, and you can calculate how much force you're going to need by the thickness. There's some really good ways to do that, but I'm not going to worry about it. That's not necessarily this. That would be for a manufacturing 2 course or a senior project. But you can make fairly complex shapes this way. And what's happening here is that it's a shearing process. This punching is basically shearing the metal apart. Now the drawing process, it's quite often done cold. You take a blank in the material, and then you force the material into a die, and it takes the shape of the die. There is a video you need to watch under the single process assignment collection. There's another thing called ironing, but you could actually get it even deeper. A lot of junction boxes, particularly ones that have solid sides, are deep drawn. Getting towards the end here, we're going to look at how pipes and tube is bent. You can have welded pipe. It can be, start with a flat strip, heat it, run it through, they can either through a series of rollers or on an extrusion part, and then gets then welded as it goes through. Can make nice pipe out of pretty thick material that way. You can also make tube by what's called piercing. You roll the solid material, or you'd start move up gradually, but as you rotate the material in the inside, it will force that pointy part in there, as the material is moving to the right, will actually force the tube to be into the shape that it needs to be. Of course, you got to stop it, because you can't run this one continuously. You can only go to the end of the rod, whereas the welded pipe, you could make a pipe that would go all the way around the world if you wanted to. Once you get it going, you can just keep going. These final processes are, well, simple folding, like the break, like you did with the artifact box, is pretty used a lot. They may use different types of breaks to bend it. You bend metal on a break, but it can be a fairly automated process, and you can get a lot of production through it. Pipe and tube bending. Now, the video that is presented in the single process videos on tube bending does a pretty good job of explaining the difference between a pipe and a tube. And this is an example of why I've had you learn screw sizes, because pipe sizes have a very similar categorization system, that if you get into an industry, whatever industry you end up in, you're going to find there's going to be some set of standards that you're going to have to adhere to. And even if you're end up as a computer networking guy, there are standards for communications that are going to be very similar to screw sizes. So pipe sizes have those same issues. And as I said before, when you bend a pipe or a tube, one part of the bend gets compressed and the other part gets stretched. So it ends up being some very interesting calculations from that. Another kind is water jet cutting, and it's usually most often abrasive water jet cutting. I mention that because there's a couple of companies here in Fresno that do use water jet cutting for making big panels. And so you might end up working for one of those companies and they do water jet cutting. A similar process, plasma cutting, can be done the same way, where you use basically a welding operation to cut out shapes. But you can also cut it out with water jet. Once you get that super pressurized water with abrasive grit mixed with it, it'll cut through metal very, very nicely, very sharply. And so you can make shapes like the shapes on the 100 Bulldog shapes that are out in front of our building. You can cut those with water jet cutting. And I believe that's it for the forming processes. There's some straightforward videos that I've posted for you to see. There's several of the single process videos are in our forming processes. So sit back and watch videos.